Hey guys, welcome back. Tonight, we're not going to wrestle with the mysteries of monarchs or the tragedies of inbred dynasties. Nope, tonight is about something bigger, something calmer, and something that, conveniently, is really good at putting people to sleep. The ocean. Now, I know what you're thinking. The ocean doesn't really need an introduction. It's the ocean. Big, blue, wet. And yet, for all its obviousness, it's still one of those things that manages to feel mysterious. Which, if we're being honest, is kind of rude. We live on this planet. It's mostly ocean. And yet we still know more about the surface of Mars than the deep sea. Classic humans. But here's the thing. When you're lying in bed, drifting off, it's actually kind of nice that the ocean is full of unanswered questions, because that means we can float around them together. No rush, no pressure, no scary cliffhanger ending, just soft, sleepy water facts. So, dim the lights, settle into the blankets, pretend you're on some imaginary ship where nothing bad ever happens, and let's glide gently across the waves of ocean trivia until you can't keep your eyes open. Let's start with the obvious. The ocean is big, like offensively big. It covers about 70% of Earth's surface. That means if Earth had a real estate listing, the ocean owned the majority share. Land is basically just a side hustle. And the volume? Roughly 1.35 billion cubic kilometers of water. If you can't picture that, don't worry. Neither can anyone else. It's one of those numbers that only exists so science can feel clever. But let's put it this way. If you scooped up all that water and poured it over the continents, the land would disappear under more than 2 miles of water. So yes, if the ocean ever gets moody and decides to relocate, it's game over. But despite being enormous, the ocean is surprisingly shallow compared to Earth itself. Picture Earth like a peach. The ocean is just the thin skin of juice on top. Most of our planet is solid rock and molten stuff we don't talk about at bedtime. So the next time you're at the beach staring at the waves, remember, you're just looking at the flimsy little puddle layer on the surface of a giant rock fruit. Now, the ocean isn't uniform. It's divided into zones, because of course humans had to complicate things by slicing it up like a giant layer cake. The top layer is called the epipelagic zone, which, let's be real, is just a fancy way of saying the sunny part. It goes down about 200 meters, and it's where almost all the plants, fish, and tourists hang out. If you've seen a picture of the ocean that doesn't look terrifying, it was probably from this zone. Below that is the mesopelagic zone, also called the twilight zone. And no, not the fun Rod Serling one. This is just where light starts to fade out. It's dim, it's gloomy, and the creatures here look like they're auditioning for a Halloween special. Fish with big eyes, glowing lures, and teeth that definitely weren't approved by orthodontists. Keep sinking, and you hit the bathopelagic zone, the midnight zone. It's completely dark, the pressure is crushing, and the temperature hovers just above freezing. Basically, it's like living in a freezer that's trying to squash you. And yet, things still live there, because life is annoyingly persistent. Below that, the abyssopelagic zone. Yes, it's called the abyss. Science did not hold back on the dramatic naming here. This is 4 to 6 kilometers deep. If you fell in, which I don't recommend, you would never stop shivering or screaming. Not that you'd last long enough to do either. But don't worry, we're not here to scare you. We're here to fall asleep. So just imagine it as a soft, endless blanket of darkness. Peaceful. Quiet. totally fine. And finally, the Hadal Zone, named after Hades, because why not make bedtime geology extra cheerful? These are the deep ocean trenches. Mariana, Tonga, Kuril-Kamchatka, all the fun places humans send robots because we are too fragile to visit. The Hadal Zone is where the pressure is so extreme it could crush submarines like soda cans. And yet, life still exists there. Worms, crustaceans, bacteria just living their best squishy lives. Let's pull back from the darkness and think about something brighter. The colors of the ocean. Why is it blue anyway? You'd think water would just be, well, clear. And technically it is. But here's the trick. Water absorbs colors of light differently. Reds, oranges, and yellows get swallowed up quickly. Blue is the color that hangs around the longest. So the deeper you go, the bluer it looks, until eventually there's no color at all, just black. But here's a fun twist. If you scoop up a glass of pure water and the light hits it just right, it actually has a faint turquoise tint. So water isn't completely colorless. It's just subtle about it, like the ocean is wearing a soft pastel filter for aesthetic purposes. And if you've ever seen tropical water that looks ridiculously turquoise, almost fake, that's because of shallow sandy bottoms reflecting more light. Basically, tropical beaches are the ocean's Instagram filters. Deep ocean, moody blue. Shallow Caribbean bay, bright teal, no filter needed. Let's float gently to another fact. The ocean is salty. Which sounds obvious, but the details are oddly satisfying. On average, seawater contains about 3.5% salt. That means every liter of seawater has about 35 grams of dissolved salts in it. Mostly sodium chloride, your regular old table salt, but also magnesium, calcium, potassium, and little chemical sprinkles. So, if you somehow evaporated all the water in the ocean, you'd be left with a crust of salt thick enough to cover the entire planet in a 150-foot layer. Imagine Earth but as one big pretzel. Not the most appetizing bedtime image, but there you go. And where does all that salt come from? Rocks. Rain falls, rivers flow, minerals dissolve, and eventually they all end up in the sea. Over millions of years, the ocean just kept collecting the stuff. Kind of like that friend who never throws anything away. The ocean is basically the hoarder of salts. Temperature-wise, the ocean is sneaky. The surface feels warm in the tropics, chilly near the poles, but once you dive deeper than a kilometer, it all evens out. Almost everywhere, deep ocean water hovers around 2 to 4 degrees Celsius, which is just above freezing. Not exactly hot tub material, but at least it's consistent. And while we're here, let's talk about currents. Because the ocean isn't just sitting still, it's moving, constantly. The Gulf Stream, for example, is like the ocean's conveyor belt. It carries warm water from the tropics up towards Europe, which is why England isn't covered in ice year-round. So if you enjoy mildly miserable rainy weather in London instead of catastrophic frostbite, you can thank the ocean currents. There are also deep currents, sometimes called the global conveyor belt. It takes a single water molecule about 1,000 years to complete the journey around the world. So if you drop your ice cube in the water tonight, don't expect it back anytime soon. The ocean is on its own schedule. One more fact before we drift further. The sound of the ocean travels ridiculously well underwater, much farther than in air. Whales can communicate across entire ocean basins. Imagine yelling across the Atlantic and someone in Europe actually hearing you. That's the whale experience, which makes sense since they don't have cell phones. Of course, human noise pollution is now messing with that, which is very on brand for us. But let's not linger on guilt. Instead, picture it. A whale song traveling slowly through the dark water, echoing softly, rising, falling, like the ocean's lullaby. And on that note, let's pause, take a slow breath, feel the waves lapping gently at the edge of your thoughts, because we're only just getting started. In the next stretch, we'll drift deeper into ocean. Part 2. Strange Ocean Life. So, now that we've set the stage with all that water, we should probably talk about the neighbors, because the ocean is not empty, not even close. It is crowded, full of things that swim, float, crawl, or just kind of blob around, looking vaguely confused. And the deeper you go, the weirder it gets, which is convenient for us because weirdness makes for great bedtime listening. Let's start with the obvious celebrities, whales. They're mammals, which means technically they're closer to you than to fish. They breathe air, they nurse their babies, and yet they look like oversized fish impersonators. Basically, whales are land mammals who got bored, wandered back into the water, and then committed fully to the bit. The blue whale, of course, is the record holder. Biggest animal to ever live. Not just now, ever. Bigger than dinosaurs. Up to 30 meters long. That's like stacking 3 school buses and then giving them fins. And it can weigh around 180 metric tons, which is a lot of gym memberships. And yet, the blue whale's diet is hilariously unimpressive. It mostly eats krill, tiny little shrimp-like creatures. So you have the largest animal on Earth, and it spends its time filter feeding like an oversized pool vacuum. Kind of humbling, really. And then there are sperm whales. They're deep divers, capable of plunging thousands of meters in search of giant squid. Imagine holding your breath for an hour and then wrestling a slippery, tentacled nightmare in the dark. That's their Tuesday. Meanwhile, we get winded walking upstairs. Speaking of squid, giant squid are the stuff of legend. Sailors told stories about them for centuries, calling them krakens, and everyone rolled their eyes, until the 2000s, when scientists finally got decent footage of one alive. Turns out, the sailors were basically right. They can reach lengths of 12 to 13 meters, with eyes the size of dinner plates. Imagine being stared at by a glowing hubcap in the dark. Not the coziest bedtime thought, but hey, at least they stay far away from humans. And let's not forget the colossal squid. Similar but chunkier. The kind of squid that skipped cardio but really hit the weights. Scientists once pulled one up near Antarctica, and it had hooks on its tentacles. Because apparently, teeth weren't enough. Nature just doubled down. But let's move to something gentler. Jellyfish. They're basically living lava lamps. No bones, no brains, no hearts. Just wobbly bags of water with a little sting. And yet they've been around for over 500 million years, which means they've survived mass extinctions that wiped out pretty much everything else. So, in evolutionary terms, jellyfish are the smug grandparents who never die. Some jellyfish can even glow. Bioluminescence, it's called. They light up in blue or green when disturbed, which, in the middle of a pitch-black ocean looks magical or terrifying. Depends on your mood. And here's a fun fact. There's a species of jellyfish, Turritopsis dorhani, that is technically immortal. When stressed or injured, it reverts back to its juvenile stage and starts its life cycle over again, like hitting the reset button on a video game. So yes, there is an animal out there that just refuses to die of old age. Meanwhile, we're over here buying anti-wrinkle creams. Now let's float over to anglerfish, probably the poster child of deep-sea weirdness. They're small, mostly under a meter long, but they look like they were designed by a child doodling monsters in the margins. Huge mouths, sharp teeth, and a glowing lure dangling in front of their faces. They use the lure to attract prey in the darkness. It's like fishing, but the rod is attached to your forehead. And the mating system? Equally strange. In many species, the male is tiny compared to the female. He bites onto her, fuses with her body, and then becomes a permanent sperm donor. Which, is one way to handle relationships. Romantic? Maybe not. Efficient? Absolutely. We can't forget deep-sea hatchetfish, named because their bodies are thin and shiny like silver hatchets. They have upward-facing eyes that are enormous to catch the faintest glimmer of light, and their undersides glow faintly thanks to photophores. This glow matches the light from above, helping them disappear into the background. It's camouflage by bioluminescence, which is impressive considering most humans can't even match their socks. And then there's the gulper eel, also called the pelican eel. It has a mouth that looks far too big for its body. When it opens wide, it looks like a broken umbrella flapping in the current. They can swallow prey almost as large as themselves. Because in the deep sea, you don't say no to snacks. You just unhinge your jaw and commit. Closer to the surface, things get a little cuter. Sea otters, for example. Not technically ocean animals, but they spend so much time in the water that we'll let them in the club. They float on their backs, hold hands to avoid drifting apart, and use rocks as tools to crack open shellfish. Basically, they're fuzzy little geniuses wrapped in damp fur coats. And yes, they're adorable. Until you remember that they also scream at terrifying pitches and steal food from each other. But hey, nobody's perfect. And then there are dolphins, everyone's favorite marine show-off. They're smart, social, and playful, which is charming, but also a little unsettling. Because the more we study them, the more they seem uncomfortably clever. They have names for each other, recognize themselves in mirrors, and coordinate hunts with military precision. Basically, they're the jocks of the ocean. Charismatic, talented, slightly smug. But of course, even dolphins aren't the kings of the sea. That crown probably goes to sharks. Specifically, the great white. They've been around for hundreds of millions of years. They can sense the faint electrical fields of prey. And despite Hollywood's obsession, they don't really want to eat humans. We're too bony, too chewy, not enough fat content. So the next time you worry about sharks at the beach, remember, you're not even on the menu. But maybe the strangest ocean animals are the smallest. Plankton. The word literally means drifter. And they come in two broad types: phytoplankton, which are tiny plants, and zooplankton, which are tiny animals. Together, they form the base of the ocean's food web. Without plankton,
everything else collapses. And here's the kicker. Phytoplankton produce more than half of Earth's oxygen. So every second breath you take, thank plankton. They're the unsung heroes, floating around, invisible, basically running the planet. No big deal. And we can't skip coral. Technically, coral reefs are made of colonies of tiny polyps. Each polyp is basically a squishy cylinder with a ring of tentacles. Not glamorous, but when millions of them get together, they build massive reef structures, bright, colorful, buzzing with life. Coral reefs are often called the rainforests of the sea, which is flattering until you remember how deforested rainforests are. But let's not spiral into eco-anxiety right now. For bedtime, let's just picture a reef. Fish darting in and out, anemones swaying, sea turtles cruising slowly like chilled-out old men. It's a gentle image, and that's the point. And finally, let's give a nod to the weird little creatures we never hear about. The sea cucumber, which looks like a squishy sausage but plays a key role in recycling nutrients. The mantis shrimp, which has eyes that can see colors we can't even imagine, and claws that strike with the speed of a bullet. And the blobfish, unfairly voted ugliest animal, mostly because it gets photographed outside its natural pressure zone. Part 3. The ocean and climate. So, we've admired the creatures. We've stared at jellyfish like glowing blobs and politely nodded at whales being enormous vacuum cleaners. Now let's zoom out, because the ocean isn't just home to things that slither and splash. It's also basically Earth's life support system. A giant, restless machine that runs the thermostat, does the laundry for the atmosphere, and quietly prevents the whole planet from going completely haywire. And the wild part? Most of this climate wizardry happens without us noticing, like a background app that never crashes. First, let's talk about heat. The ocean is basically a gigantic heat sponge. It absorbs solar energy during the day, holds onto it, and then slowly releases it back into the atmosphere. Without this, our planet would be, well, less cozy. We'd swing from boiling hot days to freezing nights like a poorly managed Airbnb. About 90% of the excess heat from global warming? Yeah, it's chilling out in the ocean right now. So the reason the air isn't instantly unbearable all over the planet is because the ocean is doing us a favor by acting like a cosmic hot water bottle. A hot water bottle that stretches 360 million square kilometers. Try fitting that under your blanket. And here's where it gets interesting. Ocean currents. Think of them as giant conveyor belts of water. They move heat around the globe. Warm water from the tropics gets shipped off toward the poles. Cold water from the poles slides back toward the equator. It's like the ocean's version of global shipping, but instead of packages, it delivers temperature. One of the most famous systems is the Gulf Stream. It carries warm water from the Caribbean up toward Europe, which is why, bizarrely, London doesn't have the same winter climate as, say, Canada at the same latitude. Instead of igloos, you get drizzle and tea, which arguably is just as depressing, but in a damp sweater-wearing kind of way. Then there's something called the global conveyor belt. Technically, the thermohaline circulation. It's driven by differences in temperature and salinity. Warm, salty water sinks when it cools, pulling more water behind it, setting up this massive, slow-motion cycle. The whole thing takes about 1,000 years to complete. So, if you're impatient, this is not the current for you. But it matters, because this circulation helps regulate the climate, spreads nutrients, and keeps the ocean from turning into one giant stagnant puddle. Imagine if someone unplugged your ceiling fan in the middle of summer. That's what losing this circulation would feel like for the planet. And, of course, the ocean does more than juggle temperatures. It also plays a huge role in carbon storage. When we pump out carbon dioxide, the ocean politely absorbs about a quarter of it. Phytoplankton use CO2 for photosynthesis, building their tiny little bodies. When they die, some sink to the seafloor, locking that carbon away for centuries. It's called the biological pump. Basically, plankton are pulling off the biggest recycling project in the world, while we can't even manage to sort our trash correctly. Now let's float into something slightly moodier, El Niño and La Niña, the ocean's version of flipping a coin, except the coin controls weather for half the planet. El Niño happens when warm surface water in the Pacific shifts eastward. This messes with trade winds, rainfall patterns, and even hurricane activity. Suddenly, places that are usually dry get drenched, and places that expect rain start wondering what happened to their clouds. La Niña is the opposite, cooler water spreading across the Pacific, flipping the chaos in the other direction. And together, they're part of something called the El Niño Southern Oscillation, a cycle that has been messing with farmers, fishermen, and forecasters for centuries. Predicting it is like trying to guess the mood of a cat. You can try, but odds are you'll still get scratched. But it's not all doom and gloom. Sometimes the ocean's climate role is weirdly poetic, like sea breezes. During the day, land heats faster than water. Hot air rises over the land, cooler air from the ocean sweeps in, and voila, a breeze. At night, it reverses. Land cools faster. Air moves the other way. It's like the ocean's way of gently fanning you while you nap on the beach. Assuming you can nap on sand, which is either romantic or horribly itchy. And tides, let's not forget tides. Technically, those are more about gravity, with the moon yanking at Earth's water like a clingy toddler. But tides also help stir the ocean, moving nutrients, mixing layers, keeping things dynamic. Without tides, coastlines would be a lot less lively. Also, we'd miss out on the dramatic reveal of tide pools, where tiny crabs and starfish pretend to be interesting for kids on field trips. Now, here's something quietly unsettling: the ocean's role in storms. Hurricanes, typhoons, cyclones, whatever you call them, are powered by warm ocean water. When surface temperatures climb high enough, evaporation fuels giant storm systems. So yes, that warm tropical vacation water you love, it can also spawn a swirling nightmare that flings palm trees like toothpicks. The duality of nature, right? And of course, as ocean temperatures rise, storms tend to get stronger, which is not exactly relaxing bedtime material, so let's gently sail past that thought and focus on calmer waters. Let's shift gears into chemistry. Because yes, the ocean has chemistry too. Seawater is salty, but it's not just sodium chloride. It's a cocktail of minerals: magnesium, calcium, potassium, sulfates, basically a liquid multivitamin. And this balance of salts influences density, currents, and even which creatures can survive where. It's like the ocean has its own recipe, and every region tweaks it just slightly. But here's the poetic part. Every bit of salt in the ocean originally came from rocks on land. Over millions of years, rain and rivers dissolved minerals and carried them to the sea. So when you taste seawater, not that I'm recommending it, you're basically sipping on dissolved mountains. A very diluted, slightly gross mountain smoothie. And speaking of sipping, let's not forget oxygen. We tend to think of the atmosphere as our oxygen bank, but actually, the ocean produces a huge chunk of it. Remember those phytoplankton? They're responsible for something like half to 70% of the oxygen we breathe. Trees get all the credit, but plankton are quietly out there doing the real work. No branches, no leaves, just microscopic photosynthetic hustle. So, in short, the ocean is not just a big blue puddle for fish, it's an air conditioner, a carbon recycler, a storm generator, and an oxygen factory. It's both calming and terrifying depending on how much detail you want to dig into, which, frankly, is perfect bedtime material. Because you can choose to imagine a soothing global system, or you can lie awake thinking about conveyor belts of water shuffling heat around for 1,000 years. Both valid options. And as we keep floating along, it's worth remembering this. The ocean doesn't care. It doesn't care if humans are impressed. It doesn't care if we panic about sea level rise. It just keeps moving. Slow, steady, endless. Like background white noise that just happens to be 1.3 billion cubic kilometers large. So next time you sit on a beach, watching the waves roll in, think about this. That gentle water touching your toes is connected, indirectly, to the Arctic ice, to Antarctic currents, to storms in the Pacific, to coral reefs glowing with life. It's all one system, humming along in ways we barely understand. And isn't that a strangely comforting thought? That something so massive and chaotic can also be steady enough to cradle life for billions of years.
Part 4. Human Myths and the Sea. So, we've established the ocean is big, moody, and essential for life. But humans being humans, we didn't stop at noticing tides and fish. We immediately started inventing stories about it. Because if there's one thing our species can't resist, it's adding a layer of mythology to anything we don't understand. And the ocean, well, it's basically the perfect blank canvas for imagination. Endless, dark, mysterious, and impossible to Google for most of history. Let's start with one of the classics, mermaids. Half human, half fish, 100% wishful thinking. Sailors swore they saw them, usually after being stuck at sea for months, half starved and half drunk. So when a manatee popped its whiskered face out of the water, they somehow thought, yes, beautiful woman, totally makes sense, which is concerning, but also kind of understandable if your diet has been salted meat and despair for 6 weeks straight. Mermaids pop up in basically every culture with a coastline. Sometimes they're friendly, sometimes they're terrifying, and sometimes they're just passive-aggressive, sitting on rocks, brushing their hair while humans drown nearby. Very on brand, honestly. Then there are sea monsters. Before sonar and satellite maps, oceans were just blank spots filled with anxiety. Medieval maps often had the phrase, "Here be dragons," which is cartographer code for, "We have no idea what's over here, so let's just doodle something scaly and call it a day." The Kraken, for example, a legendary giant squid capable of dragging entire ships into the depths. Sailors told stories about monstrous tentacles wrapping around masts, pulling crews into watery graves. And while a kraken that size has never been proven, we do know giant squid exist. They're real, they're massive, and they live in deep waters where nobody can casually check on them. So the line between myth and reality was, understandably, blurry. And then there's Atlantis, the lost city. Plato wrote about it in 360 BCE, describing an advanced civilization swallowed by the sea. And people have been obsessed with it ever since. Treasure hunters, conspiracy theorists, pseudo-historians, they all want Atlantis to be real. Spoiler, it probably wasn't. Plato was likely using it as an allegory, basically an ancient TED Talk with dramatic flair. But humans love a good mystery, so Atlantis refuses to die.
even though, if you think about it, it would probably just be another damp ruin full of crabs by now. Let's drift toward gods and goddesses, because naturally, ancient cultures decided the ocean needed divine management. The Greeks had Poseidon, salty, moody, beardy. He carried a trident, shook the earth when he was annoyed, and generally acted like the grumpy landlord of the sea. The Romans renamed him Neptune, slapped him on fountains, and kept the beard. Other cultures had their own ocean deities. In Hawaiian mythology, there's Kanaloa, god of the deep sea. In Japanese tradition, Ryujin, the dragon god, lived in a crystal palace beneath the waves. And in West African traditions, Mami Wata, a powerful water spirit, is often depicted as part human, part fish, part mystery. Every culture gave the sea a face, usually a terrifying one. Because really, who wants to worship something gentle when your livelihood depends on storms not wrecking your boat? Speaking of boats, let's float into sailors' superstitions. Seafaring has always been dangerous, so humans developed elaborate rituals to keep the ocean happy. Whistling on a ship was considered bad luck because it might whistle up a storm. Bringing bananas on board, also bad luck. Why? Because they spoil quickly, attract fruit flies, and apparently once ruined a few cargoes so badly that sailors collectively decided bananas are cursed. They also believed in sea shanties, not just for fun, but for safety. Singing together kept the crew's rhythm steady while hauling ropes or rowing, and maybe, just maybe, they thought the ocean spirits would appreciate the playlist. So the next time you hear a sea shanty on TikTok, know that it comes from centuries of sailors trying not to die in a storm by harmonizing about rum. And then there's the phenomenon of ghost ships. The most famous one, the Flying Dutchman, a legendary vessel doomed to sail forever, crewed by the dead, appearing as a bad omen to sailors, which sounds dramatic until you realize fog, mirages, and the occasional abandoned ship drifting at sea probably fueled most of those sightings. Still, the idea of a phantom vessel glowing in the mist has proven irresistible. It pops up in operas, paintings, and even SpongeBob. So the Flying Dutchman is basically the Beyoncé of nautical myths. Never really seen, but always iconic. But myths weren't just scary, they were, oddly cozy. In parts of Polynesia, navigators used star maps and the feel of waves against the hull to guide their canoes across thousands of miles. For them, the ocean wasn't a void of terror, it was a living map, a road, a guide. They sang songs encoding routes, memorized swells, and passed the knowledge down through generations. It's myth and science blurred together, practical navigation dressed up in ritual and tradition. And honestly, it worked better than European maps covered in sea dragons. Now, if you're wondering, did people ever mythologize why the ocean makes noise? Yes, the sound of waves crashing was often described as the sea speaking. Some thought it was gods whispering. Others imagined drowned souls sighing in the surf, which is a little too gothic for bedtime, but hey, people were dramatic. Even the bioluminescence of plankton, those magical glowing blue waves, got mythical treatment. To sailors, it was called sea fire or the sea's lanterns. Science tells us it's just dinoflagellates releasing light when disturbed. But centuries ago, it was a sign of enchantment, or sometimes a warning of spirits nearby. Either way, glowing waves are objectively beautiful, even if you understand the chemistry. And then there's the biggest myth of all, that the ocean was endless. For much of history, people thought the sea went on forever. Sail too far and you'd fall off the edge. Which, if you think about it, is a pretty wild thing to believe while still being willing to get in a rickety wooden boat and test it. But exploration has always been fueled by equal parts curiosity and delusion. And so myths turned into discoveries, discoveries turned into maps, and maps eventually turned into airplane routes we now complain about on layovers. Of course, not all ocean myths stayed ancient. Even today, we have modern sea legends, like the Bermuda Triangle, supposedly a cursed zone swallowing ships and planes. In reality, just a busy patch of ocean with unpredictable weather and way too much hype. But slap mystery on anything and humans will keep retelling it, because apparently we never get tired of being just a little spooked by water. So, what does all this say about us? That the ocean, for humans, has never been just water. It's been a mirror for our fears, our hopes, and our creativity. When we couldn't explain it, we filled it with monsters. When we needed comfort, we gave it gods. When we wanted adventure, we drew maps full of dragons. And even now, when we have satellites measuring sea surface temperature to the 10th of a degree, we still can't resist a good mermaid story. And maybe that's the most relaxing part, that even in our age of data and charts, the ocean still holds a little mystery. It's still a place where you can stand on the shore, listen to the waves, and imagine anything at all. Ghost ships, lost cities, glowing spirits, or just the gentle hum of water doing its thing, indifferent to human storytelling. As we drift onward, let's leave behind the myths and step into something more grounded, the science of sound in the ocean. Because if myths gave the sea a voice, science has given us microphones to hear what's actually going on down there. And, spoiler, it's weirder than you think.
Part 5. The Sounds of the Ocean. So, let's talk sound. Because the ocean isn't just blue space filled with fish. It's also one of the noisiest places on Earth. You don't hear it when you're standing on the shore. All you get are waves and maybe the distant cries of gulls stealing your chips. But underneath, in that watery world, it's a constant symphony of clicks, groans, hums, and crackles. A 24/7 soundtrack that most of us will never hear in person. And honestly, that's kind of tragic. First, the obvious one. Whales. Whales sing. You know this. Everyone knows this. There's a whole industry of whale song recordings designed to help you meditate, study, or fall asleep. Which honestly is kind of ironic, because the whales themselves are not singing to lull you into a nap. They're singing to flirt. Whale song is basically Tinder, but louder, slower, and more confusing. Humpback whales in particular are the Beyoncé of the ocean choir. Their songs can last up to 30 minutes, and then they repeat them over and over. Imagine crooning the same ballad for hours, hoping someone finally swipes right. And it works. Kind of. The songs can travel for hundreds of miles underwater, because sound moves faster and farther in water than in air. So a whale in the middle of nowhere can belt out a tune, and someone way over the horizon might actually hear it. But whales don't get the ocean all to themselves. There are dolphins, snapping shrimp, croaking fish, and even coral reefs. Yes, reefs make noise. Let's start small. Snapping shrimp, also called pistol shrimp, are tiny but obnoxiously loud. They snap their claws shut so fast, it creates a bubble that collapses with a bang. The pop is so strong, it can stun nearby prey. And collectively, when thousands of shrimp snap away on a reef, the sound is constant crackling, like frying bacon. So yes, one of the most soothing underwater sounds is basically an infinite breakfast. Fish, meanwhile, are underrated noisemakers. Some grunt, some drum, some hum. The plain-fin midshipman fish, for example, makes a droning, humming sound to attract mates, and it hums loudly. like keep you up at night loudly. In fact, in certain coastal towns, people have complained about mysterious humming noises at night, only to discover it was horny fish. So next time you hear a low hum in your walls, don't panic about aliens. It might just be fish romance. And coral reefs, they're not silent gardens, they're buzzing neighborhoods. Between fish chatter, shrimp snapping, and currents moving, reefs produce a crackling, popping soundtrack. Scientists even use it to measure reef health. Healthy reefs are noisy. Dying reefs grow eerily quiet, which is both beautiful and a little heartbreaking. Imagine your neighborhood going silent, not because everyone moved out, but because they stopped existing. That's the reef. A symphony turning into static. Now, let's drift deeper into the oddities, because humans have been eavesdropping on the ocean for decades, and sometimes the recordings don't make sense. Cue the famous bloop. In 1997, hydrophones in the Pacific picked up a loud, ultra-low sound. It was strange, powerful, and no one knew what caused it. Cue years of speculation. Was it a giant squid? A colossal sea creature? Cthulhu finally setting an alarm clock? Turns out it was ice. Specifically icebergs cracking and shifting. Which, to be fair, is still pretty impressive, but definitely less fun than an undiscovered leviathan. There's also Julia, a mysterious sound recorded in 1999. Again, speculation ran wild. Monsters, submarines, who knows? The official explanation? Ice again. Apparently, Antarctica is just out here cosplaying as Godzilla. Another odd one, the upsweep. Recorded since the late 1980s, it's a series of long, upsweeping sounds, mostly in the Pacific, still unexplained. Theories range from underwater volcanic activity to, well, no. Actually, that's it. Probably volcanoes. But I kind of prefer the idea of a massive sea creature clearing its throat every spring. And then there are sounds we've made. Humans are noisy roommates. Ships, sonar, drilling, all of it adds up. And because sound travels so well underwater, our noise can carry for miles. It interferes with whale songs, dolphin clicks, and even the humble fish hum. Basically, we've been blasting bass drops into someone else's concert, and they are not amused. Some whales have started singing louder, literally shouting to be heard over ship engines. Imagine having to scream your love ballad just to get noticed. Romantic? No. Effective? Maybe. But it's definitely stressing them out. Still, the ocean has plenty of sounds that don't involve us, like waves crashing on cliffs, seagrass swaying and rustling, the fizz of bubbles rising from vents, or the subtle, endless hum of currents moving water across the globe. It's a soundscape as layered as any forest, just harder for us to hear without special equipment. And speaking of hearing, let's pause to appreciate just how different sound is underwater. In air, sound waves bounce off particles, slow down, and fade pretty quickly. In water, sound travels about 4 times faster, and it can go for thousands of kilometers. So when a whale sings, it's not just singing to the next reef over. It could be heard an ocean away, like a very lonely but determined broadcast. There's even something called the SOFAR channel. That stands for Sound Fixing and Ranging. It's a layer in the ocean where sound travels especially efficiently, bouncing between temperature and pressure boundaries. Marine animals use it as a kind of acoustic highway. And humans, predictably, figured out how to exploit it during the Cold War. Because if there's a natural phenomenon, you can bet someone will ask, can we turn this into spying equipment? But let's not end on Cold War paranoia. Let's keep it soothing. Picture this: a calm reef at night.
Fish softly grunting, shrimp crackling, waves brushing the sand above, and somewhere, in the distance, a humpback whale humming like the ocean's own lullaby. It's not silent. It's never silent. But it's a kind of steady, living noise that feels oddly comforting. Like white noise, if the white noise was alive and occasionally dramatic. So, the next time you imagine the deep sea, don't picture a void. Picture an orchestra you can't quite hear. Shrimp on percussion, fish on bass, whales as the lead singers, and the occasional iceberg stomping in for a cameo. Not a bad soundtrack for bedtime, really. In the next part, let's drift away from sound and into light. Because if the ocean is noisy, it's also glowing in places you wouldn't expect. Bioluminescence, deep-sea darkness, and all the weird ways nature decided to play with visibility underwater. It's like a cosmic nightlight, and very on theme for falling asleep. Part 6. Bioluminescence and the deep sea glow. So, you're floating in the ocean at night, the moonlight is faint, the waves are gentle, and suddenly the water around you starts glowing. Not with neon signs, not with alien tech, but with tiny organisms lighting up like stars. That, my friends, is bioluminescence, nature's version of a glow stick. And honestly, it's better than fireworks because it's alive. Bioluminescence is basically living light. Tiny organisms like plankton produce it through a chemical reaction. It's luciferin. Yes, unfortunate name. Reacting with oxygen, usually with the help of an enzyme called luciferase. The result? A soft, magical glow. And before you ask, no, it doesn't burn them up. It's cold light, which means almost no heat. So these creatures can shine without cooking themselves alive. Smart move. Let's start small. Dinoflagellates, single-celled plankton. They're the usual culprits behind those glowing waves you sometimes see in viral beach photos. Every time the water stirs, they flash blue. It's like the ocean is sprinkled with LEDs. And why did they do this? Not to impress tourists, unfortunately. It's a defense mechanism. The glow startles predators and sometimes even attracts bigger predators to eat the smaller ones chasing them. Basically, it's an underwater version of tattling. But plankton aren't the only ones glowing. Plenty of animals down in the depths have turned themselves into floating lanterns. Because when you live in eternal darkness, glowing is the new black. Take the anglerfish, the classic nightmare creature with a built-in headlamp. That dangling lure is bioluminescent, thanks to bacteria living inside it. The fish itself doesn't make the light. It hires bacteria to do it. Freeloaders, roommates, symbiotic pals? Depends on your perspective, but the end result is a living fishing rod that attracts prey in the dark. Pretty effective, if you ignore how horrifying it looks. There are also lanternfish, and yes, the name is literal. They have rows of light-producing organs called photophores along their sides. When they swim, they look like little night lights drifting through the deep, and they're not rare. In fact, lanternfish might be the most abundant vertebrates on Earth, billions of them. So the next time you imagine the deep sea is empty, remember it's actually crowded with twinkling fish you've never seen. And then there are firefly squid, adorable little cephalopods that live off Japan. They can glow all over, turning themselves into tiny flashing galaxies. Every spring, millions of them come close to shore to spawn, and the beaches light up like someone plugged in the coastline. It's beautiful, it's romantic, and also, the squid are dying right after. Nature loves to mix beauty with tragedy. Now, some animals use bioluminescence for camouflage. Yes, glowing to hide. It's called counter-illumination. Basically, they match the faint light from above so predators below can't see their silhouette. It's like trying to erase your shadow by becoming the light source yourself. And it works. Evolution is weird, but efficient. Other creatures weaponize it. The deep-sea dragonfish, for example, not only glows, but can produce red light, which most deep-sea animals can't see. So it's like having night vision goggles while everyone else stumbles around in the dark. Sneaky. Also a little unfair, but hey, survival of the glowiest. And if you thought fireflies were cute, meet the flashlight fish. They have glowing bacteria stored in pouches under their eyes, and they can blink the lights by covering and uncovering them with skin flaps. It looks like they're winking at you. Romantic? Maybe, but mostly it's used to confuse predators and find food. So next time you get winked at, just hope it's not a prelude to being eaten. But let's come back to the surface for a second, because bioluminescence isn't just a deep-sea phenomenon. It happens in shallow waters, lagoons, and bays. There are famous places like Mosquito Bay in Puerto Rico, where the water glows almost every night. Step into it, and your footsteps leave a glowing trail, like you're some kind of wizard, except it's just science. Tourists come from all over, but the glow depends on conditions, no moonlight, calm water, and a healthy population of glowing plankton. Too much pollution, and it fades. So yes, once again, humans are dimming the lights. Let's pause here and think about how strange this is. On land, glowing is rare. You've got fireflies, a few fungi, maybe some glowworms. That's it. But in the ocean, glowing is normal, common, expected. It's almost weird if you don't glow. That's how inverted things get underwater. Now, let's mix in some irony. Humans, of course, are obsessed with recreating this. Glow-in-the-dark toys, bioluminescent street lamps. Scientists even experimented with glowing plants, because who wouldn't want a house fern that doubles as a nightlight? But here's the thing. Nature's been running this show for millions of years. We're just trying to catch up with glow stick algae. And then there's the deep-sea jellyfish Atolla wilveli. When attacked, it flashes rings of light that expand outward. It's basically an aquatic emergency siren. Instead of fighting back, it calls for help. The light show attracts bigger predators to eat whatever was attacking it. So it's outsourcing self-defense, like calling the cops, but the cops are a bigger fish. Of course, not all glowing is practical. Some of it is just vibes. Seriously, there are cases where scientists don't know why an organism glows at all. It doesn't seem to help them mate, hide, or hunt. It just glows. Maybe it's leftover evolutionary baggage. Maybe it's accidental. Or maybe, and hear me out, they just like it. After all, we string up fairy lights for no reason except it looks nice. Maybe shrimp do too. And speaking of vibes, bioluminescence has been inspiring humans for centuries. Sailors wrote about glowing seas in their journals, poets compared it to stars falling into the water, and even now, people plan entire trips around seeing it, because there's something inherently magical about it. It feels unworldly, but it's just chemistry. And that's the fun contradiction. The most mystical sights in nature often boil down to boring lab reactions. Still, lying on a beach at night, watching the waves glow every time they crash, That's something that feels like a dream. It's too soft, too surreal, too perfect to be real. But it is, right there, waiting. In the ocean. Not fireworks, not neon signs, just plankton glowing because they got bumped. And yet, it's unforgettable. So, as you drift off tonight, imagine you're swimming in glowing water. Every movement leaves a trail of light. The ocean sparkles around you. It's calm, silent, and shining. And nothing is chasing you, because this is a bedtime story, not a shark documentary. In the next part, let's sink back into the science side of things. We've talked about sound, we've talked about light, but now it's time to talk about the real foundation of the ocean, the currents, the invisible rivers inside the sea that move heat, nutrients, and sometimes your beach ball to the other side of the world. They're less flashy than glowing squid, but honestly, without currents, life in the ocean wouldn't exist. So let's follow the flow. Part 7. Ocean Currents and Hidden Rivers. All right, let's talk about the ocean's secret plumbing system. Not pipes, not drains, currents. Invisible rivers inside the sea that quietly shuffle water around like a never-ending conveyor belt. They don't ask for thanks, they just keep moving, endlessly, shaping climates, feeding ecosystems, and occasionally stealing your beach ball and sending it to Portugal. So, what exactly is a current? At the simplest level, it's just moving water. But the reasons water moves are layered and complicated. Wind, temperature, salinity, the rotation of the Earth, all of these pull strings. The result is a massive swirling dance across the globe. It's like the ocean's version of a traffic system, except with fewer traffic lights and way more detours. The most famous current, of course, is the Gulf Stream. It starts in the Gulf of Mexico, flows up the east coast of the US, and then crosses the Atlantic toward Europe. And here's the fun part. It's basically why Britain isn't covered in snow year-round. That warm water acts like a cozy blanket, keeping Western Europe's climate relatively mild. So the next time someone in London complains about the weather, remind them it could be worse. It could be Canada. But the Gulf Stream isn't alone. There's also the Kuroshio Current near Japan, the Humboldt off South America, and the Agulhas near Africa. Each one is like a character in a long, slow soap opera. They interact, they merge, they break apart, and sometimes they just drift in circles like they forgot what they were doing. Scientists even have a name for those circles: gyres. Massive whirlpools of water that can trap floating debris for decades. And yes, that's how we ended up with the Great Pacific Garbage Patch, a giant unintentional trash vortex, because humans never miss a chance to ruin a gyre. Now, not all currents are surface level. Some of them happen deep, far below the waves. This is where it gets cozy. We call it the thermohaline circulation, also known as the global conveyor belt. And honestly, the metaphor is perfect. It really is like an airport baggage belt, except it carries heat and salt instead of luggage. Warm water moves poleward, cools, sinks, and then drifts along the seafloor before eventually rising again. It takes about 1,000 years for a full circuit. So if you dropped a message in a bottle down there, congratulations, your great-grandkids might get it back. What's wild is how sensitive all of this is. Tiny changes in temperature or salinity can throw the whole system off. And yes, climate change is messing with it. There's evidence the conveyor belt is slowing, which in less sleepy terms means potentially massive shifts in weather patterns. But let's not panic right now. This is bedtime science, so let's just picture the water drifting lazily, taking its time, and hope it keeps doing that for a while longer. Currents don't just move heat, they move life. Nutrients from the deep are brought to the surface by upwelling currents. This feeds plankton, which feed fish, which feed bigger fish, which eventually feed you if you're into sushi. Without these nutrient conveyor belts, the oceans would be pretty barren. So yes, your tuna roll owes its existence to invisible underwater rivers. Romantic, isn't it? And then there's the Coriolis effect. Fancy name, simple idea. The Earth is spinning, so water doesn't move in straight lines. In the northern hemisphere, currents curve to the right. In the southern hemisphere, they curve left. It's like a global rule book for swirling. The same effect that makes hurricanes spin also shapes ocean currents. And no, it doesn't determine which way your toilet flushes. Sorry to ruin that fun myth. Some currents are seasonal. Take the monsoon currents in the Indian Ocean. They switch directions with the winds, so half the year they flow one way, the other half they flip. It's like the ocean can't make up its mind. But this indecision actually supports massive fisheries because the shifting brings nutrients up and keeps the cycle going. Indecision, for once, is useful. Currents also play games with floating objects. During World War II, entire fleets of debris drifted across oceans thanks to them. In modern times, rubber ducks famously spilled from a cargo ship and ended up traveling the world on currents, showing scientists how interconnected the system really is. So, somewhere out there, a faded rubber duck might still be surfing the conveyor belt, which is somehow both hilarious and sad. And of course, sailors knew about currents long before scientists gave them names. Navigators used them to shorten voyages, even if they didn't understand the physics. The Polynesians, for example, mastered reading swells and currents to explore the Pacific. Imagine sailing across thousands of miles of open ocean with no GPS, just an intuition for how water moves. That's not just impressive, that's borderline magical. And speaking of magic, some currents are visible. When warm and cold waters meet, you can sometimes see sharp lines in the sea. Different colors, different textures. It's like the ocean stitched two fabrics together. Sailors used to think these were boundaries between different seas. In a way, they weren't wrong. It's just one continuous ocean, but divided into invisible highways. Currents also whisper in the background of history. They carried explorers. They carried colonizers. They carried diseases. Not exactly cheerful, but true. And even today, they shape global trade routes. So the same hidden forces that once guided Polynesian canoes now also guide massive shipping containers full of, let's be honest, Amazon packages. If you were to map currents, it would look like veins across a body, pumping, pulsing, distributing energy. The ocean isn't static. It's alive in a way because of these endless flows. And without them, Earth would look very different, maybe not livable. So the next time you feel a current tug at your legs at the beach, don't get annoyed. That's just a tiny fragment of a planetary system that quietly keeps you alive. Now, let's drift to something more visual. Because while currents are invisible, they create visible patterns. Swirls of plankton glowing at night, lines of seaweed gathered at the edges of gyres. Even migrating animals follow currents, like turtles hitchhiking across oceans. It's nature's Uber, and it doesn't charge a fare. And yet, for all our technology, we're still mapping these flows. Satellites can see surface temperatures and track movement, but the deep, slow rivers remain mysterious. We drop floats, measure salinity, model simulations, and still the ocean shrugs, keeping secrets. That's the thing about currents. They're constant, but not fully understood, like background music you notice only when it stops. So, as you close your eyes, picture yourself floating in one of these hidden rivers. Not rushing, not crashing, just drifting, carried along by forces older than civilization. The water is warm, the stars above are steady, and the current knows exactly where it's going, which, honestly, is kind of reassuring. In the next part, we'll sink back into the creatures again, because currents may move nutrients, but it's the animals that make things colorful. And few are as colorful or as strange as coral reefs. Bright, crowded, chaotic neighborhoods in the middle of the sea. So let's go visit the ocean's version of a downtown block party, the reef.